You're listening to the Autism Weekly podcast. Each week we share community voices and bring light to stories that increase awareness, acceptance, equity, access, and inclusion. If you haven't already, subscribe to join the Autism Weekly family. I'm your host, Jeff Skibitsky. This week we're joined by Anila DeMello, an assistant professor at UT Southwestern, whose groundbreaking research uses neuroimaging to explore the brain circuits that support language and cognition in autism. Dr. DeMello will share insights from her work on cerebellar circuits and how they differ in neurodevelopmental disorders. Join us as we discuss how these findings can transform our understanding of autism and inform future interventions. Welcome to the podcast, Anila DeMello.
Thank you. I'm happy to be here.
Well, I'm excited. This is a topic we just chatted right before, but this is something that's relatively new for me as well as somebody who's been in the field for about 25 years, is that it excites me. I love seeing research that maybe hasn't come to the application side yet, that as clinicians we can learn about, start exploring, and start trying to digest how we see this applying in the future within our work and our fields. But before we go there, one thing I love to be able to do, because I think anybody who works in the field of developmental disorders or who works with neurodiversity at all, they have a connection to the field in some way. And I'd love to hear your story of what sparked your interest in the field of autism.
Yeah, that's a great question. So I came to autism from a really weird route, which is that as a kid and in high school, I was always interested in kind of communication. So how do people communicate with each other? How do people interact with each other? And so when I applied to college, I thought, oh, what I really want to be doing is political science, right? That's the study, right, of how people talk to each other, how they communicate. And so I went to Georgetown University in Washington, D.C. to do that. And then I took a psychology class and realized, well, actually, what you want to be studying if you're interested in communication is individuals, right? And is how people interact with each other on an individual basis, not societies. And so I became interested in language and cognition. And that's how I came to autism. Because, as a condition, people with autism, autistic individuals have, oftentimes struggles or differences in the domains of language and social communication. And so I thought, wow, this could be an interesting way to not only research how to best support autistic individuals, but also to kind of maybe discover basic mechanisms of how language works in the brain for all people, right? Not just autistic individuals.
No, absolutely. And I mean, when you're talking about communication, you're talking about the ability to be able to engage in the social settings and to be able to empower yourself to be a part of all of those environments around you.
Right.
Communication, socialization, those things are so important.
Right.
But there's so many ways for us to learn about them. And one of those is what you've been doing a lot of your research on. And I'd love to just kind of walk our audience through, because when we're talking about anything that has to do with the nervous system, the brain in general, I think it's complicated not only for us, but even for a lot of researchers. We're still getting more information and digging deep. But can you give us a little bit of a background of how the process works when you're talking about the cerebrum and the circuits being able to kind of work with the frontal cortex to be able to get some of the communication going?
Yeah, for sure. So you're right. So it can be complicated. So basically, what researchers like myself do is we like to study the brain. But to do that, right? So in the past, historically, people would wait for someone to die. They'd open up, a brain and they'd be able to look at it and poke at it. And so that's clearly not something that we want to be doing, right? So what we have are these amazing tools. So a slate of tools, of neuroimaging tools, which basically allow us to peek into the human brain in people as they sit, as they think, listen to stories, as they, watch movies. And so these are tools that basically allow us to look at the structure of the brain. So, how big it might be, how different regions of the brain might be different sizes, the organization of that structure. So how different regions are connected to each other through, these white matter pathways that connect different regions, allowing them to talk to each other. So we can measure that. And we can also measure the function of the brain. So we can have someone lay in an MRI scanner and we can take pictures of the brain while they do something. So while they listen to a story or they look at a face. And by doing that, we can identify different regions of the brain that are active when people are doing those kinds of tasks. And then by looking at a lot of different people doing these things, right, we can start to identify differences, right? So how might one person differ from another person, depending on context or depending on individual differences between people?
Mm-hmm.
So that's
Absolutely.
basically the fundamental, right, tool and what we use to study the brain.
So I'm going to bring you all the way back to what you left so long ago in political science, but
Yeah.
I'll go back to a little bit more, I guess, the anthropology. I mean, when you're talking about neurodiversity and you're talking about autism, there's a culture around it. And when you're studying a group of people, what is it are there any kind of attributes that are common when you're looking at those MRIs and people who are neurodiverse or identify autistic that we should know about?
Yeah, so this has been so this is actually a big question, right, in neuroscience research and also in my own research, which is, how much can we say that a group of people is the same in a certain way or different? So there are some truths about the brain, right, and in all people, right, there are parts of the brain that do certain things. Brains, even across different kinds of people, are organized in more or less the same way. But of course, within that, there's individual variation. This is true in neurotypical individuals, and it's definitely true in neurodivergent, individuals. And in fact, it may be more true. There may be more differences and more variability in neurodiverse populations, right? So like individuals with autism. So, and I can give you an example of this, right? So some of our work has tried to find regions of the brain that are important for kind of processing sensory things, right? So we know that some autistic individuals have some challenges processing sensory stuff in their environment. They have hypersensitivities. And so what we found is that in neurotypicals, there's a number of brain regions that are important for this kinds of processing. And neurotypicals tend to overlap. A lot of them use the same brain regions to do this kind of stuff, right? So when they're processing a face, they tend to use the same set of brain regions. But we have some work now. So this is a study that we're doing in collaboration with a grad student at MIT. Her name is Amanda O'Brien. And what we're finding actually is that autistic individuals tend to not overlap as much in the brain regions they use. So while neurotypicals use the same set of brain regions to do something like sensory processing, autistic individuals tend to use many different brain regions to do that, right? And so this might kind of explain some of the heterogeneity that we see. And it's a really important consideration when we're thinking about the science, right? Of how are we interpreting brain findings and what parts of the brain are we looking at? It's
Mm-hmm.
not just that there may be differences, but autistic individuals may differ not only from neurotypicals, but also from each other in ways that are very different from neurotypicals.
Yeah, I've never thought about it that way, where you have like almost like this bucket of neurotypicals that's right here, as far as how they're processing maybe some of these sensory experiences. And when you're talking about neurodiversity, it's all around. Like, I mean, some of it could be in the gap right in the middle, but then you see it kind of each individual is so different as far as how they're going to process, but it's not in the same, they're not all categorized the same. They're not all following the same path, which makes sense when you're talking about trying to be able to find appropriate ways to treat or to empower individuals that you really need to know them individually. So maybe that's where we kind of steer the conversation a little bit is you've been doing a lot of work on communication, and I'd love to know what you're finding about that relation and how communication is actually working when you're studying the cerebrum and the cerebella.
Yeah. So, it's difficult, right? It's difficult to know. So communication is such a complex thing, right? Language is such a complex thing. So it involves not only listening right? But understanding, so taking words, putting them together into meaning. If you're reading, right, that's kind of a different form of communication, even though it's based in part on language. And if you're communicating socially, well, that's a whole different thing that involves vision and hearing and social processes. So something that we've been interested in is trying to identify what parts of the brain might be contributing to those things, right, in neurotypical individuals, and how there may be differences in the function of those brain regions in autism. So as you mentioned, we focus a lot on the cerebellum. So this is a part of the brain that has been historically really ignored in neuroscience. People think it's really important for things like balance or reaching, things that allow you to move. And so forever, neuroscientists have really ignored it.
Hmm.
But it turns out that 80% of the cells in your brain, so 80% of the neurons in your brain actually live in the cerebellum. And only 20% of the cells in your brain live in the rest of the brain, right? In places like the cerebral cortex, the prefrontal cortex, these parts of the brain that we know so well. And
Mm-hmm.
so we've tried to understand, well, what is it? What parts of the cerebellum are really involved in these higher order cognitive domains? And so us and many others have identified specific regions of the cerebellum that are active for language and that are connected to regions like the prefrontal cortex. And connections between these regions we know are important for language, and they're altered in conditions where language may be difficult, like some individuals with autism.
So what sort of findings have you been able to find that could guide eventual practice? Because as you're talking about all this, I'm thinking, okay, well, if I'm able to understand a little bit more about what circuits are firing and what is triggering the communication and the way that it's coming out and the process of that, I feel like, as I'm evaluating my any sort of treatment or any sort of support services, that you can start to see, okay, well, I'm getting to that other part of the brain which might be needed, or I'm activating more, or I'm getting more concise. I don't know which way you want to go, but is that you'd be able to use that information to be able to guide individualized treatment. But what have you found that's been almost like wow or enlightening through the process that you're like, this is going to be something groundbreaking that's going to help in the care for autism in the future as well that, practitioners should hear about?
Yeah. So I can give you for like a very broad answer, and then I'll give you a specific example of something. So really broadly, I think you're absolutely right that the idea of something like neuroimaging and understanding these circuits and how they differ in autism, the idea is that, you might be able to identify in an individual person, what might be a specific challenge or strength for that individual. And then based on that information, you might be able to personalize some sort of intervention or supports that you don't have to wait for it to fail or not work, right? Before you identify what that intervention is, right? And that could happen really early in development when we know that supports and interventions are the most important. Um, and it can happen because neuroimaging is non-invasive. It can happen in a number of different people. So unlike something like a standardized assessment, which requires you to talk or interact, or is standardized and might not be applicable for a non-speaking person or a nonverbal individual, the promise of something like neuroimaging is that it could be applicable to anyone. Some neuroimaging technologies don't require you to do anything, right? And so the promise then is, could it be broadly applied to several people to identify in those individuals what would be the best course of action to to personalize an intervention to that person? And I can give you an example of one way that we are starting to do this. So in most science on language, for example, we tend to have a bunch of people and we treat them all the same. We put them in a scanner and we have them listen to stories, for example, and the stories could be interesting to some people, but they could be boring to others, right? And then we look at their brains. And using these kinds of techniques, we found that a lot of language regions are different in autism. Something that we have started doing, though, is saying, well, anecdotally, autistic individuals tend to have things that they're particularly interested in, so special interests or affinities, right? what would happen if instead of generic stories, we had them listen to things that were interesting to them, that were personalized to them, right? And that's not the way science or assessments and diagnostics are typically done. And so this is a study that we're doing in collaboration with Dr. Haley Olson at MIT and Dr. Christy Johnson at Northeastern. And basically what we did was we had kids, autistic and non-autistic, come into the scanner and we had them listen to generic stories, and then we had them listen to stories that were personalized for them. So we did interviews with kids and their families about things that they were most interested in. So trains or Minecraft or whatever it was, right? And we recorded stories based on these interests. And what we found was that the brains of autistic individuals and neurotypical children as well were much more active for things that they were personally interested in than generic things. And so some of the differences that it looked like were existing in autistic individuals might have been a product of the way we were doing our science, right? So if you do the science differently, if you use things that are personalized to the individual, we start getting maybe a different picture of what the linguistic brain, the language network of the brain actually might look like. And we think this is really critical to think of, both from an intervention standpoint, but from a neuroimaging science standpoint. So in interventions, we're often told, don't engage kids on their special interests. They might talk about them forever. But we're finding that, well, maybe in the brain, the brain really likes these things. Maybe it could open a door for some sort of, powerful intervention. And from a science standpoint, we're thinking, well, wow, maybe some of the ways that we were studying the brain, we're not really accurately capturing the capacity for language in individuals. And the best way to do this is actually to personalize things to the person. So I think these are ways in which our kind of basic science approach can translate into some sort of understanding or into some sort of, clinical benefit for people. Oh, sorry, you're muted.
I love the way that you were thinking through that, because it's almost giving the validation to what we're seeing in
Yes.
everyday life is that, and this isn't just neurodiverse people, it's that it's neurotypical as well, is that when you're talking to somebody and they are engaged on the subject, you're going to
Yeah.
see everything change. They're going to process differently. They're going to engage with their body differently. They're going to show attention. Probably their sensory systems are going to change, which means,
Mhm.
like you were describing, the brain is processing everything in a very different way than if
Right.
somebody has zero interest. And I could see applications of this, of trying to be able to make sure, especially during learning phases for a lot of children or young adults and adults that maybe need to have that sort of input in a very specific way, it could help them to acquire new skills even faster and make it so that they have this whole library of skill sets that they can now access in a quicker fashion. And then you can normalize it over time with some of the distractions that occur in everyday life, but they have the skills. They got them in the belt and they
Yeah.
can use them in such a practical fashion.
Right. And I
That
think
is
it plays into a strength, right, of autism. And I think in science, and I'm not a clinician, right, but in what I know of clinical practice, those things are sometimes not as emphasized, definitely in science, right? We focus a lot on understanding why things are wrong rather than
mhm.
saying, well, what are strengths and what are the basis of these strengths and how can we use those to kind of bolster challenges in other domains? So,
Absolutely. I mean, whether it's clinical work or in the workplace or in the research lab, it's like if you can tap into everybody's strengths, it makes the world around us that much better. And it really gives people that self-fulfillment of
that's
I can
right.
be a participant, I can be empowered, and I can contribute in any way I want. So when you're talking about the MRI, is that I'm thinking a lot of equipment. I'm thinking that it's going to be cumbersome. But then again, you see technology out there, you see AI out there, you have ways that it feels like accessibility is becoming more and more available to just everybody that would like to be able to be a participant. Am I wrong to assume that neuroimaging is becoming more, I guess, portable?
Yeah, so yeah, you're absolutely right that right now, right, to do an MRI on someone, someone has to come to a facility, and the MRI is this huge machine, right? And you lay down in this machine and it takes pictures of the brain and then we can analyze those pictures. So in terms of accessibility, right, for research purposes, participants, we pay volunteers to come
Mhm.
and take part in our studies. Now, of course, traveling to these sites, right, traveling to these universities, is more possible for some people, not as possible for others. Um, and getting in the fMRI scanner can be challenging, right? Like this is it's a tube, for people who've had MRIs of their knee or something like that, like, right? It's a, it's a big tube. It can be a little scary, right? So,
Mhm.
so that's a problem with accessibility. Yeah, so people are working on making these technologies more accessible, not so much with MRI, but there are other technologies like EEG, which allows us to kind of understand electrical signals that are happening in the brain. Um, FNIRS, which is another technology, right? Those technologies could be portable, right? You could
Mhm.
you could maybe do them, you could maybe even, eventually kind of bring them into the home. MRI is not quite there yet. It's not quite
Okay.
there yet. The machines are big, but the environment is not inaccessible to people
Mhm.
who do want to participate.
So I would imagine even those participants that are engaging in the research is that they're coming away empowered and knowing a variety of information points that will help enhance whatever part of life they're going to be utilizing it, is that knowledge is powerful. Have you heard from any of the participants that, "Hey, I took my child or myself and I went through the process of doing the neuroimaging, and I walked away feeling like, I have so much more understanding, or I can empower those around me differently now that I know this about myself or my child."
Yeah, so, usually for research purposes, we don't, we can't say anything. We're not clinicians, we're not doctors, right? We can't say anything to participants who come in about their individual brains, right? I hope what participants walk away with, and some have talked about this, right, is kind of the power that they've contributed to science, and they've contributed to bettering knowledge of autism, of language, of the brain, knowledge that then gets published, that people can read and build off of, and so knowledge that eventually, right, the goal is going to, you know, inform things like supports and interventions, and so the participants are a critical part of that, right? And critically, they're volunteers. So they are doing this out of the goodness of their heart, basically. And
Yeah.
so I think that is powerful, right? That these are people from the community who say, hey, science is important. It might not
Mhm.
change my life, but it might change someone else's life. And and they choose to participate.
Absolutely. And just the idea of being able to pay it forward and to be able to contribute in that way, I would imagine for most families, it helps that next family down the line.
Right.
But it probably helps with being able to gain more resources to be able to continue the research. So those ideas of, advanced technology or more understanding or being able to integrate these into complex healthcare systems and have a way to be able to make the use more easy to implement on a daily schedule. I think that those are the components. Where are you going next with your research? I mean, it sounds like you've kind of already given us a hint of what you're working on next, but it feels like it's also endless possibilities. So where are you
It's
moving?
endless possibilities. Yeah, so I think the approach that we've taken is basically really broad. So autism is complex. Autistic individuals differ from each other. They differ from neurotypicals. And so our approach has really been to kind of investigate autism from a number of different angles. So we have several studies. Not all of them are about language and social communication. Some of them are about cognitive inflexibility, how challenges in adapting to new events in the environment are not only a challenge in many domains, but might also be adaptive in certain circumstances and when those might be. We have some cool research with collaborators trying to develop new methodology and tools for this kind of work. So how do we address the unique needs of autistic participants who, might not all enjoy the scanning environment or might have difficulties with certain things that we ask them to do in the scanner. So how can we make sure that our research is addressing those needs, right? So that the results we're getting are not only more accurate and more valid, but also the experience is better for autistic participants. So we are kind of attacking this from all angles, right? Trying to incorporate, right, what we know about autism, our past experience, and develop new tools too.
So you mentioned that you have paid opportunities for participants to come in, but with the amount of research that you're trying to be able to put out there, to be able to share with everyone, and so we can move the field forward on a regular basis and make all these astounding discoveries that will help to not just empower neurodiverse people, but better understanding of the brain in general. So how do folks that are interested get involved? Because they can't all go to Dallas. So how can they make sure they can contribute in some way?
Yes. So in every city in the United States, even rural areas, in every city in the world, there are researchers that are doing autism research. And these are researchers who would love for more people, children, adults, females, males, whoever, right, to be involved in their studies. So, a really easy way to kind of get involved is to go online and look at what local universities or medical centers in your area are doing. Most often, right, researchers there will post on their websites that they're recruiting participants to take part in different studies, and those studies will have certain criteria. So check out websites, check out these opportunities because participants really are so critical for our research and for setting the research directions that scientists then pursue, right? Which is very important.
Absolutely. And for those that are practitioners or those that are invested in technologies within the field of neurodiversity, is they're probably integral in the next stage of all the work that comes out. They're taking the research, they're trying to create the product, they're trying to create the service line. Where can they find your research so that they can start to learn a little bit more of what's on the horizon and start potentially planning on some of these other sorts of research projects, which may be more about making something available to the market or something that's available for the consumer in general?
Yeah, definitely. So, for my work in particular, all of that kind of literature that we've published is on our website. A lot of it is freely available if you Google, the names of the authors, such as mine, on the internet. And I routinely have people email me as well to ask for copies or to ask science questions. And so, researchers are very happy to talk with other people about what it is that they're doing, and getting clinical involvement and clinical collaborators is really, really important to kind of the mission of making sure that the research isn't just out there floating. It's meaningful and it's addressing the concerns of people in the community.
No, and I encourage those that are out there that that partnership between research and innovation and technology is crucial for all of us to be able to kind of really continue to move things on within our field. So I encourage folks to reach out and see what you've put out there, Anila, and your colleagues that are working on similar things. It just enhances our knowledge base and hopefully creates more passion.
Yeah.
But thank you so much for coming on today. Once again, it's like I feel like I've learned a lot on a topic that I did not have a lot of exposure to historically, and it gave me the itch to go and kind of start looking at some of this research myself to try and really get a better understanding. So thank you so much for coming on.
Thank you. It's been really fun.
Thank you for listening to Autism Weekly. We hope you tune back in next week to learn more about autism in the real world. Autism Weekly is now found on all the major listening apps, including Apple Podcasts, Google Podcasts, Stitcher, Spotify, Amazon Music, and more. Subscribe to be notified when we post a new podcast. Autism Weekly is produced by ABS Kids. ABS Kids is proud to provide diagnostic assessments and ABA therapy to children with developmental delays like autism spectrum disorder. You can learn more about ABS Kids and the Autism Weekly podcast by visiting abskids.com. Thanks for tuning in. See you again next week.